The last part of section 7.7 deals with transformations of logarithmic functions. So let's talk about this particular topic. First of all, the parent function of all log functions is y equals log base b of x. That's the parent function. And if you recall from our earlier discussion on logs, the domain is always x is greater than 0, and the range will always be all real numbers. Now, when you transform log functions, and again, I'm going to color code it like I did the last video, the transformed log functions are y equals a times log base b of x minus h, and again, the h is in parentheses right next to the x, and then at the very end is the plus k part. Works the same way as everything else. One more time, what does a control? A is the stretch or compression factor. And again, if the absolute value of a is greater than 1, it's a stretch. Or if the absolute value of a is between 0 and 1, it's a compression. The h value moves the graph horizontally. But in this particular case, also the line x equals h is the vertical asymptote. Because remember, log functions also have a vertical asymptote, so the line x equals h is that. And finally, the k value does just what it always does. It moves the graph vertically. Same thing. Now, how do you know what the domain is? The domain is always x is greater than h. Whatever h is, that's what your domain is. The range will always be all real numbers. All right, let's look at a couple examples. Given the transform function 5 log base 3 of x plus 6 minus 2. First of all, what is the parent function? Well, the parent function is just log base 3 of x. This number, and that number have nothing to do with the parent function. Okay? Now, the y-intercept. Remember, there is none. There is none. The equation of the asymptote is the line x equals negative 6. Because this is in the form x minus h. That number, the h value, is negative 6. That would be the equation of your vertical. I'm going to put the word vertical in here. Your vertical asymptote. The domain, that number right there. X is greater than negative 6. The range, as always with log functions, the range is all real numbers. And finally, how is f prime of x, how does that transform the parent function? Well, first of all, it stretches by a factor of 5. Stretches by a factor of 5. Secondly, that negative 6 moves the graph left 6 units, and the negative 2 will move it down 6 units, or 2 units, sorry. There you go. That's how you deal with transformations. Now, let's do some graphing. All right, first of all, let's graph the parent function, y equals log of x. And so I'm going to fill in x and y. And what we're going to do is we're going to type that equation in on our calculator. and we're going to go to our t-table. Well, you notice if x is 0, it says error. Can't do it, because remember our domain, you have to pick all numbers that are greater than 0. Otherwise, you get an error. Well, I'm just going to go up by 0.5s. Let's go 0.5, you get negative 0.30. Let's say at 1, you're going to get 0. Let's jump up to, if we go up to 3, you get 0.47. I'm just taking a random sample here. Let's go up to, if you go 7, it's 0.8. All right, so I'm going to graph this in blue. At 0, it's an error. At 0.5, it's negative 0.3. Oops. Somewhere over there. Somewhere in this area here. And then 1, 0. And then 3.47 and 7.8. So again, as best as I can do on the smartboard, it's going to go something like this. And remember, it's got a vertical asymptote. Since you cannot pick x values smaller than 0, it's got a vertical asymptote right there. All right, so there's our log graph. Now, let's graph the transformation graph, which is right here. 2 log x plus 3 minus 1. Well, let's go all the way down here where it says transformations to begin with. First of all, what's going to happen? Well, it's going to be stretched by a factor of 2. It's going to move left 3, and it's going to move down 1. All right, well, the most important thing is this left 3, because what that's going to do is move our vertical asymptote left 3 spots. So our domain is going to be all numbers greater than negative 3, because of that number right there. So I got to pick all numbers greater than negative 3. Well, I'm actually going to start with negative 3, and let's go negative 2, negative 1, 0, 1, 2, and let's see what happens. The range, hopefully, will be all real numbers, just like it always is for the log function. Same over here. I forgot to write that one in over here. All right, so let's look at our calculator. Let's type in this equation to your calculator, and let's go find our table values. Well, at negative 3, it says error. That agrees with what we just said, because it says x has to be bigger than negative 3. At negative 2, it's negative 1. At negative 1, it's negative 0.4. At 0, it's almost 0. It's negative 0.04. Positive 1, now we're up in the positive numbers at 0.2. And 2 is about 0.4. So I'm going to graph this one in red. Negative 3 is the error. Negative 2, negative 1 is right there. Negative 1, negative 0.4 is about right there. 0, and now we're in the positives just barely. 1 over 1.2, it's going to be about right there. And 2.4, it's going to kind of overlap our other one. Now, again, since I cannot pick negative 3, that line, the asymptote for this graph, the asymptote is the line x equals negative 3. That vertical line. So I'm actually going to draw that vertical line in black right here. The graph, our red graph, is not going to cross that line. And I think you can kind of see that. It's going to bend, and it's going to go down like this. And then this way, it's going to go like that. So actually, our graph did shift to the left 3 and did shift down 1. And that's how you do transformations for log functions.